Hi guys, in this video we will be solving the today's GeeksforGeeks problem of the day, and the name of the problem is next permutation. So here we will be given an array of integers representing a permutation, and we need to implement the next permutation that will rearrange the numbers into the lexicographical next getter permutation. So let's see what does it means. Suppose they had given the example as 3 to 1. Let's take it, make some changes in that example, and it is suppose 3 1 2. Okay, and let's find out what are the possible permutation for this combination. First one will be 1 2 3, then 1 3 2. Okay, so these are the total 6 possible combinations for this array, and we need to find out the next lexicographically greater permutation. Okay, so here it is 312 and 312 comes here, and all these numbers are in ascending order. So we need to find out the number which will be greater than this, and that particular number is this one. So this one will be the answer for this combination. Okay, and in question they had given the combination as 3 to 1. So here 3 to 1 resembles to the last one, and there is not a greater lexicographical combination below it. Okay, so they had considered it from the start, means they had gone to topmost one and returned it. So for this question they had given the answer as 1 2 3, and in this example you can see 241750 is there, and the next permutation is 245017. So up to 2 and 4 it will be same, but after 1 in this combination there is the fifth number which is the greatest, and 017. Okay, to solve this question there is a algorithm that we can implement. So let's see how we can make it. First takes the example what it is, 241750. Okay, so this is the given example, and we need to find out the next lexicographical greater number. So we are going to follow some steps, and that particular steps are, we need to find out an integer, an index we can say, and that index we will start from backward, so that any number I should be less than I plus 1. Okay, this is the first condition that we are going to do. What it does means that we will be starting from this position, and we will check if this number is less than this one. If it is not, then we will move the I to the next position. So here it is 7. We will check if 7 is less than 5. It is not, so we will again move it to the next position, and as it reaches first position, or the first, as it points toward 1, we can say that this number is less than this number, and we can return out of the for loop. So first condition is we need to check array of I is less than I plus 1 from the ending point. Okay, so doing this, this is our original array 4175 and 0, and I will be pointing toward this one because we had reached a point where I is less than I plus 1. After that we need to check if I is less than 0, if I reaches at negative position, and all this array is in we can say that all the numbers, or we can say that it is a last permutation combination, and we had seen in the start that it had reached to the bottom, and if it is a bottom then we need to go to the top position, which will be the all the elements of array will be in the sorted order. So we can check is if I is less than 0, then we can reverse whole array, and the answer will be that thing. Okay, or else the next condition is we need to return from here because we don't need to move further. If array we had fully bigger permutation. Okay, then after that what we need to do, we need to we need to carry another index j, and that will be starting from end point, which will be n minus 1, and the condition for that thing is, and the condition for this one is, if we find array of j is greater than array of I. Basically we need to find out I, we need to find out j such that it will be pointing from end 1, and that element should be greater than the ith one. So in this scenario we will be searching for this part, it should be greater than the ith one, and here there is only one element, which there are two elements which are greater than I, which are 5 and 7, but as we are starting from end point, as soon as we reach here we will get our element and we will stop it. Okay, and when we stop it, after stopping it we found out j, which will be at this position, and I will be at this position. Then we need to swap the array of I and array of j. Okay, so till this point the answer will be 2 4 1. Oh sorry, it will not be 1 as we are swapping the ith element and jth element. So jth element will be 5 7 and 1 0. Okay, after swapping we will get this one, and after that what we are going to do, we are going to reverse the array from the position greater than I to end. Okay, got it. So here it was I pointing, and we are going to reverse this particular part. So the final answer that we will get is 2 4 5 0 1 and 7. Let's compare whether it is our final answer, and you can see it is our final answer that we had got. Okay, so this was all about problem. If we get the numbers to validate this condition, if I is greater than 0, they had given the example as 3 to 1, where the I will be pointing towards the before the starting point, which will be in the negative form, and then only thing we need to do is we need to reverse the array. Okay, so let's try to code what exactly we had seen. First we need to check the ending point. If it is negative, then reverse the whole array and return out of the function. If not, find out the jth index, then swap the position of I and j, and then reverse the array from one position greater than I till the end. So let's code it. So first let's take the size of the array, which will be array.size. After that we need to declare the I, because it will be same for the code. So int I we had declared it, and I will be less than, sorry, I will be n minus 2, and we need to iterate it till less than equal to 0 and I minus minus. So here we are going to check if array of I is less than array of I plus 1, and if this condition hits, then we need to break the execution and get out of the for loop. If I is less than 0, we had discussed if it is an greatest permutation through lexicographical, then we need to only reverse the whole array and then return it. If it is not the case, then we need to find out the j. So we will try to declare j at the top only. Here j will be from ending position, which will be in -1, and j should be greater than 0 because we are not going to move one step ahead of I, and we need to decrement the j. So here we need to check if array of j is greater than array of I. In that scenario, we have found our j and we need to break out of the for loop. Okay. After all these steps, our last step is swap the array of I and array of j. After swapping it, we need to reverse the array from the position greater than 1 greater than I till array dot end when we are good to go. So let's try to compile it and check. So it given the compilation error. Oh, no matching function for start. Okay, I had placed a comma here. It should be dot. Okay, we can see the expected output is the same as we had provided. Now let's try to submit it. Oh, zero test case passed. What's the problem? One more thing we had done wrong is that I had placed here I by mistake. So I need to place J. Let's try to submit. Okay, so the problem is successfully solved, and in this way we had solved today's problem. Only thing is we need to remember these 5 steps and we are good to go. Okay, in next video we will see tomorrow's problem, and if you want daily updates about Geeks for Geeks problem of the day, you can subscribe to my channel. So till then, bye bye. Thank you.